50 kilogram box lies on the floor of a 400 kilogram lift. The system accelerates upwards at 2.2 meters per second squared. So, let's suppose that this is the lift, and we've got the box just here. The first thing we want to do is find the tension in the cable raising the lift. So we've got a tension acting this way. We know the system is accelerating upwards at 2.2 meters per second squared. Acting downwards here would be the combined weight of the lift and the box, and therefore 450 G. So, using F equals ma, the resultant force is T minus 450 G, and that's going to be equal to 450, which is the mass, times 2.2, which is the acceleration, and therefore T is going to be 450 times 2.2, add 450 times 9.8, if we take G is equal to 9.8. So 450 times 2.2, add 450 times 9.8, gives me 5,400 newtons. Now in part B, we want to find the reaction force between the box and the floor of the lift. So if we just consider the floor of the lift and the box, and we're going to have 50 G downwards, and the reaction force between the box and the floor of the lift acting upwards. We know the acceleration of the system is 2.2 meters per second squared upwards. So once again, using F equals ma, I have R minus 50G is equal to 50 times 2.2, and therefore R is going to be 50 times 2.2, add 50G. And then we can calculate that. So we've got 50 times 2.2, add 50 times 9.8, giving me 600 newtons.